So continuing from the previous video, we stopped here. When you set list 1 at index 0 to oil volume, what that does is it replaces the first item in the list with oil volume. So first item in list 1 is TOIP, right? So it will become oil volume. So when we print list 2, which is an alias to list 1, so it is basically the same as list 1 in computer's memory. So you have changed what is stored in the computer's memory from TOIP to oil volume. So when you print list 2, you are in fact printing list 1 because list 2 is list 1, as you saw from the true results right here. So when we print list 2, this is what we get. So oil volume becomes, TOIP becomes oil volume, and the others remain the same. How about this? List 2 at index 1, which is area. We want to replace it with reservoir area. And then we print list 1. List 1 is list 2, list 2 is list 1. So basically you will get oil volume, reservoir area, porosity, permeability, like so. So this area has now been replaced by reservoir area because the second item in the list, which is at list 1, has been changed from area to reservoir area. And when you print list 1, you're basically printing list 2, right? So same deal. But list 3 never changed, right? Because we grabbed a copy at this point in time. So all these changes to list 1, which is same as list 2, doesn't affect the copy of list 1 you grabbed at this level. Remember, computer programs in Python and in most other languages run from top down. So we copied list 1 at this level when it was TOIP, area, porosity, and permeability. So when you print out list 3, it's going to still be these values, which is what you see right here. Lists can contain a mix of strings and numbers. It could be integers, double point precision, complex numbers, binary numbers, and so on. You can have different data types within a list, and I mentioned that at the very beginning. And when you print it here, it just prints out whatever you stored in test list. Tuples are another type of collection, and it is ordered, meaning you can index it from 0 to whatever the length is, -1, right? And then it is unchangeable, so it is immutable. In lists, we talked about the identifying lists from square brackets like so, right? If you have done this, then this will be a list. Well, for tuples, you just need to open and close your parentheses, and that will create an empty tuple. And you can print it, it's going to return an empty tuple, which will look just like this empty parenthesis. So we can run this, and that's what you get from the first print statement. And then you can get the type, right, using the same type function. So we are printing the type of my tuple, and it's from the class tuple. What if we want to initialize a tuple with values? Remember, for lists, you will use square brackets and then provide the items separated by commas. Here, you're providing the item also separated by commas, but engulfed in parentheses instead of square brackets. And you can have a tuple of only one item, and you just need to have this comma after the integer. So if you don't put this comma here, it isn't a tuple. It's just 50 in parentheses, right? The comma is really what indicates the tuple, even though we had said the parenthesis indicates the tuple. Yeah, but the comma is very important. So you can actually have a tuple of one value without the parentheses. The comma is really what defines the tuple. But when you print it out, yeah, it's going to come out in the parentheses like so. You can have a tuple for numbers like this. Previously we had used square brackets, and those will be lists. Parentheses will indicate tuples. Why do we care about tuples? Why use tuples? Because they are faster. So calculations are faster on tuples than lists. So we can declare this tuple and print it out. We can set my tuple to these 4 values because my tuple contained 4 values separated by a comma. So remember the variable assignment we had talked about before. It basically uses tuple implicitly. So 2 we get assigned to A, 8 we get assigned to B, 3 gets assigned to C, 1 gets assigned to D. And then we can print them all, and then it's going to show 2, 8, 3, 1 without the commas, right? Because this is just a print statement for multiple variables. Your tuples are immutable, like I said, meaning they can't be changed. So I put a comment here that Python will not allow you to insert items into or remove items from a list, from a tuple, I should say. And then like lists, which are like strings in the sense that you can add, you can use the plus sign, and it isn't adding, it concatenates. So this will concatenate tuple 1 to tuple 2. And these are tuples 1 and 2. We can print it out and obtain these results. So you can actually append integer tuples to string tuples. You can index tuples because they are ordered lists. They are ordered collections just like lists. So we can access the first item in the tuple. So we have my tuple defined here, 2831. So the first item will be at index 0, so that will print out 2. This will grab the last item, which is what? 1. And this, just like this, right? It will start out, it will end 1 short of the last item, because this is -1 and it's to the right of the column. So we don't get to the last item we have here. So it's going to be the penultimate item, which is what? 3. That's at -2. This is -3. This is -4. And we start from -4 all the way to -1. So it's 2, 8, and 3. We don't get to -1. So this will give you 2, 8, 3. And you can see the tuple is clearly seen because it's surrounded by parentheses. A tuple will provide these values, integers and strings. Can contain a mix of them. We print the tuple, it's just going to look just like this, and we can delete the tuple, and that means it's gone from computer memory. And if you try to print it after deleting it, or you try to do some calculations, then it's going to complain and say the variable isn't defined. Even though tuples are immutable, meaning they cannot be changed, you can actually change them. How? By storing mutable objects in the tuple. So if you store a list which is mutable within the tuple, then you can change the list that is stored within the tuple, and that essentially means the tuple is changing. So that's just some small caveat to note, that even though we say it's immutable, If you store a list like so in it, you can actually change this list, which is stored within the tuple DOM D. So we can test for equality, right? And equality is comparing the content of the two tuples, and it's identical, right? So that will return true. Is DOM the same as D? Meaning, does DOM refer to the same location in the computer's memory as D? Meaning, is DOM an alias for D? It isn't, right? These are two different strings, so they are stored at different locations in the computer's memory. So this will be false, and we can run it. And you see the first is true, the second is false. To know exactly whether two objects occupy the same location in the computer's memory, you can actually use the ID function. And it's an inbuilt Python function. It can give you the address of objects in Python. Alright, so every object has its own unique ID, and the ID gets assigned when the object is created. The ID is basically the address, the memory address of the object in the computer, and it will change every time you run your code. So if you run the same code multiple times, it can store the object in different positions in the computer's memory. But like you see here, some objects have constant ID. Those are just details. So we can find the address where DOM is stored in computer's memory by calling ID with DOM, ID with D, and then we can print these two out, and that's what the IDs are. So you can see this ends in 04, this ends in 40, so they are stored at the same content is stored at two different locations in the computer's memory, and these are the memory addresses. You can create a new, maybe not say create a new variable, we are creating an alias to DOM, right? DOM is assigned to tDOM. So if you change DOM, tDOM changes. If you change tDOM, DOM changes. tDOM is a reference to whatever is stored in the computer's memory location where DOM is stored. So tDOM, DOM, same deal. If we print both of them, they're going to print the same thing, right? And if you test for equality, it's checking if what is in tDOM is equal to what is in DOM, and that is true. Is tDOM same as DOM? Is it an alias for DOM? And the answer is yes, because we just set it equal. If you wanted a copy of DOM, then you use DOM.copy, right? Like we had in lists. So x equals 3. So I'm just showing that this behavior that you see for many collections, actually for most collections, which is when you use the equal sign, you're actually doing you're actually creating an alias. That behavior is common with most of the collections that contain multiple data items. But with single or primitive data types like you have here, these are primitive data types. What you have is pass by value, meaning values get copied. So x is equal to 3. When you say y equals x, you're actually copying what is stored in x into a new location in memory y for the primitive data types. So y and x are not aliases, right? Y is not an alias to x, as you would have if x were a collection like a list or a tuple. So, important here, x is copied into y. This is passed by value. Whereas here for a tuple, which will be the case for a list too, what you have is passed by reference. You don't copy it. It's the same object. You only created an alias to DOM. Z is 4.3, Y can be changed to 5.2. And when you change Y to 5.2, does X change? No, because Y is a copy of X. It isn't the same as X. And when you look at the IDs of all three variables, they will all be different because we didn't create an alias. We just copied values here. You can see this is 60, this is 88, this is 68. Three different locations. Y is not X. It is a copy of what was in X. And then some quick exercise. What do you expect when these lines are run? Skills equals tdom1. What's the second item in tdom? Tdom is DOM, and DOM is what? Here, it's a list, right? So DOM refers to poetry pretend fights. That's what we should get when that is run. You can check that out. tdom is not defined. Why? Because we didn't run this, right? So we have to run this first, and then we have defined tdom, and then we can go back here and run this, and then it shows up exactly what we expect. That list is the second item in the tdom tuple, second item right here. What else? Skills.append wrap. So after the last item in DOM, we're going to append wrap as a string to this. So now the item contains, the collection contains 3 items. And if you print it, that's exactly what you get. The original contents and then wrap. Then we print DOM. tdom is an alias for DOM, right? tdom is an alias for DOM. So whatever is stored in DOM is what is stored in DOM. And it's dynamic. If you change what is stored in DOM, what is changed in tdom changes. And that's why you see this is exactly, you're printing DOM, same as printing tdom. Point to the same location in the computer's memory. Print DOM equals to D. So you're checking, is DOM equal to D? And the answer is true originally, but now because we've changed DOM, right, by changing tdom, so these two will not be equal anymore. So that's why it's false, right? Originally they were the same right here. See that? But we have appended wrap to DOM. So what is contained in DOM is now different from what is contained in D, and that's why it's false. And in the last video, I'll talk about dictionaries. So I'll stop this one right here.